Hello friends, myself R.D. Mahajan presenting my video on residue. Let us define that residue. There are two formulas to find the residue. The first one, if it is a simple pole at the point z is equals to a, then residue at that point z is equals to a is given by limit of z minus a multiplied by f of z as z tends to a. This is the first formula. Then second, residue at a pole of order m at the point z is equals to a. That point z is equals to a is a pole of order m. Then the residue at that point z is equals to a is given by 1 upon m minus 1 factorial multiplied by m minus first order derivative with respect to z of z minus a raised to m into f of z, and after finding that derivative, its value at z is equals to a. Then the theorem, important theorem, that is residue theorem, its statement is like this: let f of z be an analytic function within and on a simple closed curve C. That C curve is a simple and closed curve, except at a finite number of singularities, that is z1, z2, z3, so on, zn. These are the singularities. Singularities means at that point the function is not analytic. Otherwise it is analytic. Therefore, once again I will repeat, let f of z be an analytic function within and on a simple closed curve C, except some finite number of singularities, that is z1, z2, z3, so on, zn inside C. Then that control integral of f of z with respect to z over that closed curve C is given by or obtained by 2 pi I multiplied by summation of residues of f of z at z is equals to zi. I changes from 1 to n. Therefore, with using this formula, we can determine the value of that control integral. How? That I will explain with two simple examples. First example, evaluate control integral of 2 minus 4z divided by z multiplied by z minus 1 with respect to z over that closed curve C mod z is equals to 1 by Cauchy's residue theorem. And therefore, first of all, we try to find out the pole of that function f of z. F of z is here 2 minus 4z divided by z into z minus 1. Equating denominator terms to 0, we get first one as z equals to 0, second one z minus 1 equals to 0, that is z is equals to 1. These are the two simple poles. Then we check whether that lies inside or on or outside that curve C, and therefore mod of z at z is equals to 0, mod of 0 is 0, which is less than that radius 1. Therefore, point lies inside. Curve C. The second point, mod of z at z is equals to 1, mod of 1 is equals to 1, that is equals to 1. Therefore, point lies on that curve. And as that point lies inside and on the curve, we try to find out the residue. As both are simple pole, we get residue at first pole z is equals to 0 is limit of z minus a is here 0 into f of z. F of z is 2 minus 4z whole divided by z multiplied by z minus 1, and limit as z tends to a, z tends to 0. And therefore, we get this z gets cancelled. We have limit of 2 minus 4z whole divided by z minus 1 as z tends to 0. Substituting the limit as z equals to 0, we get here this term as 0, this term as 0. Therefore, it is 2 divided by minus 1, and therefore the value is minus 2. The first residue is minus 2. Residue at the point z is equals to 0. Then we determine the residue at the second point. Residue at point z is equals to 1. Once again applying that formula. As it is simple pole, it is limit of z minus a is 1 into f of z. F of z is 2 minus 4z whole divided by z into z minus 1. Z minus 1 get cancelled, and limit as z tends to a, z tends to 1. And therefore we get that value as limit of remaining terms are 2 minus 4z whole divided by z as z tends to 1, and therefore we get that value as, put z is equals to 1 here, we get 2 minus 4 into 1, that is 4 divided by 1, therefore that term is minus 2. 2 minus 4 we get minus 2. The second residue is minus 2. And then we apply that Cauchy. Then applying Cauchy's residue theorem, the value of that control integral 2 minus 4z whole divided by z multiplied by z minus 1, and its integration with respect to z over that closed curve C is 2 pi I into sum of the residues. And therefore we get that value as 2 pi I multiplied by sum of the residues. First residue is minus 2, second is also minus 2, therefore sum of that 2 is minus 4 into that 2 pi I, we get that value as minus 8 pi I as the answer or the value of that control integral by applying Cauchy's residue theorem. Second example, evaluate control integral of z square divided by z plus 2 multiplied by z minus 1 whole square, and its integration with respect to z over that curve C mod z is equals to 4. Standard circle, center at origin, radius 4. And therefore, to evaluate it, given function f of z is z square divided by z plus 2 multiplied by z minus 1 whole square. Then we determine the poles. Equating this denominator terms to 0, we get the first one as z plus 2 is equals to 0. That is z is equals to minus 2, simple pole. Simple pole means it is pole of order 1. Then the second one, z minus 1, equating it to 0, we get z is equals to 1. It is pole of order 2. Then we check whether that lies inside or on or outside the curve. Therefore, mod of z at z is equals to minus 2. Mod of minus 2 is 2. It is less than 4. Therefore, point lies inside. That curve C. The second one, mod of z, that is mod of 1. Mod of 1 is 1. Again less than 4. Radius 4. Therefore, that point also lies inside. That is, point lies inside. See, this is the second step. First step, get the pole. Second step, check whether that lies inside or on the curve or outside the curve. And then try to find out the residue. The first one is a simple pole, and therefore the residue at simple pole z is equals to minus 2 is given by limit of z minus a, minus of minus it becomes plus, therefore it is z plus 2 into f of z. F of z is z square divided by z plus 2 into z minus 1 whole square, and as limit z tends to A is here minus 2. Therefore, this z plus 2 get cancelled. We get limit of remaining terms are z square divided by z minus 1 whole square as z tends to minus 2. And then taking the limit of substituting z is equals to minus 2 here, we get that value as minus 2 square, that is 4, divided by minus 2 minus 1 minus 3 and its square. Therefore, that value is 4 by 9. The first residue at simple pole z is equals to minus 2 is 4 by 9. Then we determine the second. Then we try to determine the residue at that pole of order 2. As per the formula, it is 1 upon m minus 1 factorial. M is here 2. Therefore, 2 minus 1, that is 1 factorial. And same order derivative, that is first order derivative of z minus 1 whole square into this function z square upon z plus 2 into z minus 1 whole square. This z minus 1 whole square, z minus 1 whole square get cancelled. We get remaining term as 1 upon 1 factorial d by dz of remaining terms are z square divided by z plus 2 at z is equals to 1. And then differentiating it by quotient rule, u by v rule, we get that value as v is here z plus 2, derivative of z square is 2z minus z square, differentiation of this term z plus 2 is 1 whole divided by v square, that is z plus 2 whole square, and its value at z is equals to 1. And therefore, we get 2z square minus z square, remaining is z square plus 4z whole divided by z plus 2 bracket square, and this value at z is equals to 1. And therefore, substituting z is equals to 1 here to get the value of that second residue, we get 1 square as 1 plus 4 into 1 we get 4 divided by 1 plus 2 3 square, and therefore that value is 5 by 3 square, that is 9. This is the second residue. And then we apply that Cauchy's residue theorem to get the value of this contour integral. The value of that contour integral, integration of z square divided by z plus 2 into z minus 1 whole square, and its integration with respect to z is equals to 2 pi I into sum of the residues. And therefore, substituting the values of residue 1 and residue 2, we get 2 pi I. First residue is 4 by 9, second residue is 5 by 9. We get that value as 2 pi I, 9 by 9, adding this, it is 1, and therefore we get 2 pi I into 1, the value is 2 pi I as the answer or the value of that contour integral by applying Cauchy's residue theorem. Therefore, in this video, I have discussed two types of problem. The first one containing simple pole, and the second problem containing both simple pole as well as pole of order 2. Some more I will discuss in my next video. Therefore, if you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.